Hello, everyone. Welcome. I think most people should be here by now, but yes, so I'll get started. Dear participants, good afternoon or morning, evening, depending on where you are. Great to see many familiar names in the audience. For those who do not know me, I am Julia van Frans, Policy and Advocacy Officer at I4E. And welcome to another webinar in the Innovation for Electrification series. We created this series to bring our members one step closer to potential collaborations by giving them the opportunity to directly showcase their products and solutions. So I'm happy to kick off this third edition of the 2025 I4E on energy storage and recycling best practices. Sorry. Yes, as many of you might have seen already, we launched a newsletter on the same topic as well yesterday. So feel free to check that one out either on our website or in your own inbox. Maybe I'll go straight to the topic of the day itself and the agenda. So overall, as mentioned, the topic of the day is energy storage and recycling best practices. And the DRE sector, as you know, is rapidly expanding, driven by the need for clean, reliable, and affordable energy solutions to achieve energy access. And to fully realize the potential of this sector, effective energy storage and recycling strategies are essential. So therefore, this webinar will delve into the latest best practices for optimizing energy storage systems to maximize the value of renewable energy generation. Different members will showcase and explore various storage technologies, their applications and economic considerations, and clearly present their state-of-the-art solutions. So that's on the webinar. And then additionally, the webinar will also address the critical importance of circularity as a fundamental element to achieve our decarbonization and energy transition goals. Overall, we have 6 members who will be presenting today and explain their projects and solutions. My colleague Carlos, whom you might already know from previous editions, will introduce them in a moment. But yeah, and on the slide, on the presentations, actually, before anyone asks, do note that these will be recorded and made available on the I4E website. And yes, so if you have any questions, feel free to drop them in the chat with the name of the speaker your question is addressed to, and then I will make sure to get back to you either during the session and pending on time, maybe also afterwards as a follow-up. So maybe quickly on I4E itself. Next. Yes, thank you. So yeah, just a quick recap for those who do not know us. I4E, Alliance for Rural Electrification, is the global business association representing 200 members along the DRE value chain, the decentralized renewable energy value chain. We work to expand sustainable electricity access, create jobs, and respond to climate change across Africa, Asia Pacific, and Latin America. Next slide. So our global presence, as you can see on the map, illustrates where our members work. And as you can see, a large part of the work of our members is in Africa, Asia, and Latin America. We ourselves, I4E, we're renewable energy, or we're technology agnostic. That means that our members work across all technologies from energy, hydro, wind, power components, energy storage, solar PV, hydrogen, etc., for example. And not only in terms of technology, but also in terms of system size, we're agnostic. So our members work on grid-connected, standalone, and mini-grid solutions, for example, all powered by renewables. Then going to our membership services. Thank you. So our mission is to improve private sector-driven markets, and so therefore I4E provides services to its members in this regard. And these services include business and market development support, capacity building, policy and advocacy, as well as communications and marketing. Well, in case any of you would like to know more about this, what I4E does, and or join the family, I4E family, feel free to reach out to any of us, any I4E colleagues after the webinar. Before I hand over to my colleague Carlos to introduce the members that will present, I would like to briefly highlight a project that I4E has been working on recently on integrating circularity practices in the DRE sector. Thank you. And so, yes, well, to introduce the topic more globally, as you all know, batteries are used in many applications, from cars to DRE systems, such as, well, mini-grids, for example. And as the proliferation of DRE solutions inevitably increases due to the demand to address the growing, well, demand, as said, in Africa, and to electrify the more than 600 million people lacking access to electricity. Therefore, the demand for batteries, logically, also increases, which leads to growing end-of-life battery volumes that need to be soundly managed and recycled. Although everyone is aware that we need technology and recycling in many regions of the world, recycling takes place in substandard, highly dangerous and unsafe conditions often, exposing workers and neighboring communities to hazardous substances. This does not only occur in the informal sector, but also, and even to a larger extent, unfortunately, in the low standard industrial smelting, for example, from licensed and registered recyclers. So that is quite remarkable to note. And because of, well, and why? Because in unregulated markets, low standards of industrial smelting, for example, is highly profitable. Therefore, as a result of that, the Partnership for Responsible Battery and Metal Recycling, so the PROBAMET in brief, was launched, which looked into battery recycling in Nigeria in particular, raising labor and environmental standards and establishing sustainable trade flows for raw materials. The project, which was supported by GIZ, as you can see here above in the, according to the logos, you can see the project was implemented by these partners. So you can see the Öko-Institute, the Environmental Research Institute, who coordinated the overall project. Then there was the think tank SRADEV, which stands for Sustainable Research and Action for Environmental Development. Platform Blei, or Platform-led, if you translate it, an initiative of the, well, in German again, Wirtschaftsvereinigung Metalle, so it's a yeah, another associated, well, a grouping, let's say, representing the non-ferrous metal industry and I4E itself. But clearly, to ensure the success, we also sought out some associated partners, such as the Ministry of Environment in Nigeria, Nesrea, and the Alliance for Responsible Battery Recycling, for example. But overall, this initiative, yeah, maybe indeed to the next slide. As part of this initiative, let's say, I4E developed this circularity guideline, calling on the DRE sector in particular to be aware of these consequences of, of not recycling batteries correctly, and to ensure that they themselves, therefore, make sure that batteries are procured that, well, those batteries are procured that are known for their durability and longevity to minimize early replacements, clearly, aside from the cost factor, obviously. And then also that they employ repairable and recyclable system designs to reduce waste and replacement needs. A third element in the guidelines is that at the end of the life cycle, the DRE companies would ensure sound management of all batteries, and that they would ideally partner with best available recycling facilities. You can see the guideline here, well, a small version of it. Feel free to look at the QR code to see the real version and the longer version of it in more detail. Overall, now, so far, more than 90 companies have signed the guidelines, and we clearly call on the entire DRE sector to endorse the guidelines and commit to implementing the guidelines in your daily operations. This is relevant across the entire value chain, really. So it's not just for project developers who think of which batteries to include in their systems, but it's really from, well, across the value chain. So even including investors, for example, for them to integrate it into their requirements, for example. It is also a shared responsibility by all actors. So we really would like to call on everyone indeed to endorse these guidelines. There's a link to a template letter if you like to make it easier for you when you follow the QR code. So yeah, thank you. With that said, if you have any questions on this initiative or on the guidelines, either or, feel free to reach out to me at any point. You can see my contact details in the next slide, and feel free to reach out. And yes, wishing you all an insightful webinar, and I hand over to my colleague who is the facilitator going forward. Thank you.
Thank you very much, Julia, for this presentation. I think it's the best way to start with the topic of the day, and also to present the work of I4E and the policy efforts that we are currently doing. So yeah, good morning, good afternoon, good evening, everyone, ladies and gentlemen, joining from all over the world. My name is Carlos. I'm Business and Market Development Associate at I4E, and today I have the honor, the pleasure of being the moderator of this magnific session, this I4E webinar, today on the topic energy storage and circularity. The context of this webinar has already been explained by my colleague Julia. She also talked about I4E itself. So we will go deeper into the different presentations right now, and it's going to be a very insightful webinar with a lot of different companies showcasing their efforts. Before that, just a couple of points. First of all, dear speakers, please try to stick to the time so that we will have enough time in the end for covering the Q&A session and to answer the questions from the audience. And second point, dear audience, please make sure to ask as many questions as you want, given that we will have this Q&A session and you will have the chance of interacting with the speakers via chat. I will be directly redirecting the questions from you to the speakers, and they will have the chance of explaining and going deeper into some other points. So having said that, I'm happy to present the first speaker of the day, and that would be in the next slide, Mr. Tomas Verhaeghe, who is the CEO of Batrica, and he will be talking about the efforts of Batrica in order to electrify Chad. So thanks, Thomas, and the floor is all yours for the next 8 minutes. Thank you very much.
Good afternoon, everyone. Thank you for giving me the floor. And I would like to thank I4E for the opportunity to speak today and to have this great audience. So I will present Batrica to a nice audience. So I will start with giving you a bit of a background on Batrica and myself. So I'm Tomas Verhaeghe. I've been working in the energy sector for more than 13 years now. I'm working for the group of company called Novum, and Batrica is part of this group of company. Novum was at the beginning only focusing on utility scale projects, working across Africa. For example, in Namibia, we have a bit more than 100 megawatts of power plants in operation or under construction. In Senegal, 20 megawatts of solar energy in production. In Morocco, 36 megawatts of wind energy in production, etc., etc. Comoros Island, Chad, etc. But before Batrica, all of our project was utility scale projects, grid connected with no battery. And while we were developing those projects, we realized that there is a huge market for electrification in Africa. In fact, the latest value that I have is that more than 500 million people has no access to electricity in Africa, and there is a very slow electrification rate progress over the years. As you can see, we went from 33% to 46% recently. So, and we can even notice that the rural electrification is declining. So from Novum moving to Batrica, we realize that there is a huge market and that maybe there is no real solutions to answer these huge markets. So we try to look at what is the needs for electrifying Africa. And World Bank says that people need more or less 50 watt hours per day for lightning and cell phone charging. And World Bank also is saying that the existing solutions cover only 15% of the markets because of high costs, regulatory barriers, or oversized systems. So as we speak right now, mini grid, solar home system, grid extensions, all those solutions are very good. They have great advantages, but they are not meeting the demands. They are meeting only 15% of the demand. So based on these statements, we created Batrica. I'm the CEO of this company. And next slide, please. And we try to develop a solution that will meet the demands for most of the people and not focusing only on the 15% of the people. So to do so, we are trying to get advantages of the best solution of every system that works at the moment, mini grid, solar home system. And we try also to take advantages of the improvement in technology. So with battery system, we realize that there is a big advantage where we can centralize the production of electricity. So we have all our solar modules in one place. We centralize the productions. The solar modules will charge our batteries, and those batteries will permit to consume the electricity remotely. And thanks to the battery, because they can be hand carried, we don't need to install power lines anymore. We don't need to install meters anymore. So we are saving a lot in terms of CapEx. So by centralizing productions, we optimize what is complicated, meaning producing electricity. And by using small batteries, we decentralize the consumptions without using power lines. How it works on a day-to-day operations, solar modules are charging batteries. The batteries are then collected by local agents that has been trained by Batrica, and those agents, they will hand deliver the battery to end customers. To use the battery, it needs to be unlocked first, and to unlock the battery, you need to do mobile money prepayments. Once the payment has been received, the battery will unlock automatically, and the end customers can use the battery for 24 hours. After 24 hours, we collect the battery back and we plug it again in our charging station, so the battery can be used again for a new cycle. So here, and why it is quite interesting to talk about this solution in this webinar, is that thanks to the new technology or the improvements of battery systems, we were able to optimize rural electrification in Africa. Next slide, please. So far what we have done is we have installed 25 hubs in 25 villages of Chad. So we have a bit more than 7,500 batteries deployed in Chad. And with these 25 hubs, we have performed so far a bit more than 600,000 rentals over the next from the last 2 years. And we are today making a bit more than 2,500 rentals a day. the number of customers that we have registered in our platform is about 25,000 people. And we are, thanks to our 25 stations, we are, Batrica give energy service to people in Chad, and we meet the demand of more or less 100,000 people in Chad. So it's quite impressive to see that with tiny solutions, and we have huge impact locally in terms of affordable and clean energy access and education, safety, etc., etc. Next slide, please. I will elaborate a bit more what we have within the hubs, because this is the topic of the webinar today. So as I mentioned to you, we have solar modules installed on the roof, and those solar modules, they will charge our main battery system, which is a 10 kilowatt-hour battery system. This 10 kilowatt-hour battery system will then be used to charge our small battery, 50 watt-hour battery, that can be, after that, hand carried to final customers. Why we are happy with the rental model is because we, by renting the battery, the end customers does not have to do any investments. We are carrying the investments, so people can use the battery only up to their needs and when they need it, meaning that we are affordable to as many people as possible. In fact, we can see that 80% of our customers are renting the battery only once a week, meaning that those people that we are offering energy access cannot really either afford more than once a week, or they don't really need more than once a week, meaning that a solar home system or mini grid won't be the solution to them. So we are very happy with the battery rental model because it is accessible to many, many people, much more than other potential solutions. And last and most importantly, the rental models gives a lot of responsibility to Batrica because we remain the owner of the battery. So if the battery has a default after the afterlife of the battery is and remains our responsibility. So what we do at the moment is every time we have a battery that has a default or is not performing well anymore, we collect this battery, we store it, and once we have enough battery, we can send it to a recycling or sorting center. To date, I must be honest with you, we didn't collect enough battery to do so. So we have only a few batteries that is underperforming that we are storing properly at the headquarters. And as soon as we have enough, then we will be able to send to the sorting center. So that's how we handle the afterlife. But at least we are the one responsible to it. We don't transfer this responsibility to the end customer. Maybe next slide, please. Is it the end? Yeah, okay. So I wanted to, sorry, I've been very short. I wanted to stick to the 8 minutes available to me. And I'm definitely gonna stay much longer for the Q&A portion. So if you have any question, please feel free. And it was a pleasure discussing about this nice opportunity of using battery system in Africa for rural electrification. Thank you very much.
Thank you, Tomas. The pleasure is ours. Thank you for the great presentation. Your work is really inspiring, and the numbers you showcased today show the impact. It's really, really good to see. And you mentioned it's a tiny solution that is creating a lot of impact, and it's very good to see your efforts in the sector. So thanks a lot. I'm sure that the audience will have many questions for you and the business model and how can it be applied to different markets. So yeah, thanks a lot, Thomas.
Definitely, I wanted to elaborate much more, but with the time left, I thought it was better to make it short.
Yeah, but then in the Q&A you can. Thanks, Thomas. So now I will invite to the next speaker of today. That if we can go to the next slide, that will be Mr. Mikel Valderrama, who is representing another member of I4E, that is CEGASA Energía. So Mikel, it's a real pleasure to have you here today for this panel. And yeah, the floor will be yours for the next 8 minutes. Thank you very much in advance, and looking forward to your presentation.
Okay. Perfect. Can everybody see me? Yes.
I can hear you, but not see you.
Huh. Of course. It's not working right now. I don't know why. Why?
It was at the beginning.
Yeah, I don't know why. No, it's not working. Give me a second. Yeah, sorry. Here, I think it's because of this. Okay. Okay, now, yeah.
Now
sorry.
Okay. No worries.
Technical difficulties. Yeah. Well, hi everybody. Welcome. Today I'm going to share with you how battery energy storage solutions play a key role in the electrification of rural and remote areas, and how they also adapt depending on the situation or the requirements. Next slide, please. My name is Mikel. I'm one of your hosts for today, and I'm the current business development manager for the African continent here in CEGASA. Here you have all of my contact information, so if you want to send me an email, please feel free to do so. Next slide. Just as a brief explanation about CEGASA, we are a company with more than 90 years of history. And in all of those 90 years, we have gathered quite a lot of expertise in the electrochemical and electronical part of energy storage. And all of our products are designed and manufactured here in our facilities in the north of Spain. Of course, the solutions follow the European standards. Our specialized R&D and engineering department make sure of that. And we also have laboratories where we test all of our batteries and where we also test the different inverter manufacturers' models. Thanks to all of this, we have collaborated in more than 500 projects across the world, and we have installed more than 150 megawatt hours of energy storage. Of course, for us, it's not only important to provide our customers with the highest quality energy storage solution possible, but also to give them the best service possible. It doesn't matter if it's for technical staff with customer service, if it's with training, if they need it, but also to assist our clients and our customers before, during, and after the projects. Next slide, please. So if we take a look about the current situation of electrification worldwide, there are 688 million people without any kind of electricity access. And more than 600 million of those people are in developing countries. If we take a closer look at that specific number, 588 million people are in sub-Saharan Africa only, and 70% of those 588 million people, quite many people, are located in rural and remote areas. Of course, electrification is quite important for those areas in order to have good health, well-being, quality of life, of course, also for the children to have education, economical development of the areas, and also for the environmental sustainability. So they use renewable energies instead of, for example, diesel generators. In order to achieve this, however, there are many difficulties in the way, like the geographic isolation of these areas, the infrastructure limitations, and the extreme weathers, for example. And also the fact that they have quite a heavy reliance on fossil fuels, and the fact that the populations in these areas is of quite a low density makes the change from diesel generators, for example, to renewable energy sometimes quite expensive. Next slide, please. So in this case, we must adapt to our customers to these complex environments. So the variety and adaptability of the solutions is key for this. Here in CEGASA, as you can see, we have different solutions for low voltage projects or installations or high voltage, it doesn't matter. But also, apart from that, we need to have quite many strategic alliances. We need to have flexibility in terms of the inverter manufacturer that we work with. Here in CEGASA, we work with Victron, CACO, SMA, Solis. But if, for example, we have to work with an inverter manufacturer that we have never worked with, there wouldn't be any problem either, because here in our factories, we could test all of our batteries with that inverter manufacturer. And we also have the support of our engineering department, our R&D department, or our after-sales department. So just as some examples, let's say that we have a project, a microgrid project in low voltage. Well, in that case, we could provide them with the EBIC LV solution. But let's say that now the project is in high voltage and we don't have any kind of room where we can store the battery modules and its components. Well, in this case, we could also provide them with a container solution that we have available here in CEGASA and in high voltage. But as a last example, let's say that the project is in high voltage, we don't have any kind of storage room available, and then we have weight limitations during the transport. Well, in that case, we could also provide them with a cabinet solution, which is much more compact than the container, and that it weighs much less. Next slide, please. So just as an example of one of the projects that we are currently collaborating on, here you have one of the projects in the north of Congo, in Yemena. The requirements of our customer were that we had to provide them with a solution of more than 20 megawatt hours of energy storage. The solution had to be in a 40-foot container, and also it had to be in high voltage, and it had to withstand high temperatures. If we take a look at the difficulties of this project, the container had to weigh less than 20 tons because the containers are going to be transported across the Congo River on boats. Of course, the containers have to be easy to transport and also detachable, meaning that maybe we have to transport the components individually due to the weight. So in this case, we can provide our customers with our E-Rack container solution that weighs less than 20 tons, and it has liquid cooling, so it can withstand the high temperatures of the area. But let's say that the container solution weighs more than 20 tons. Well, in that case, we could provide them with the E-cabinet solution, the one that I showed you before. But hypothetically, let's say that the E-cabinet weighs more than 20 tons as well. Well, in that case, we could also send all the components of the E-cabinet individually, the battery modules, the BMU, the inverter, and everything to the customer, so it weighs less than the minimum requirement. Next slide, please. So just to sum up some conclusions, rural and remote electrification for these areas is crucial, of course, in order to achieve a quality of life and also economical development in these areas. Of course, the solutions that we have to provide to these, well, in these projects, to these areas, they have to be adaptable and also fast to deploy. However, if we take a look right now at the combination of renewable energies and energy storage solutions available, they are quite great and they are improving each day. However, like I said, it's not only important to provide them with the highest quality energy storage solution, but also the manufacturer's assistance is of the utmost importance. Next slide, please. And this was everything from my part. I thank you very much for your attention. I really appreciate the opportunity that the area gave me. And if you have any questions or you want to send me an email, feel free to do so. Thank you very much.
Thank you very much, Mikel, for showcasing all your work and all the efforts of the CEGASA. As we all know, it's a huge company with many years of expertise, and yeah, it's very interesting to see all the sectors working, and also especially interesting the case study in Congo. So thanks for showcasing that. As Mikel mentioned, feel free to reach out to him or to type any question in the chat with the Q&A function of GoToWebinar. So yeah, thanks, Mikel. Now I will have the pleasure of inviting the third speaker of the day. That would be Christopher Pai, representing ComAp, also one of our board members in I4E. So yeah, it's always a pleasure to hear about the work of ComAp. So thanks, Chris, for your participation. And again, the floor is yours for the next 8 minutes.
Thank you, Carlos. Thanks for the introduction, and thank you, I4E, for the opportunity to speak once more in this latest innovation for electrification series. From my side, maybe just a quick introduction on ComAp. We are a technology business focused on control systems for power applications. And essentially my segment, so I'm the segment manager for hybrid microgrids and responsible obviously for this area of the business as well as the portfolio that we offer into the market. So this session is more of an informational session, more of a knowledge sharing session rather than a product plug, because as a technology agnostic sort of business, our focus is to bring technologies and energy sources together, and we have run with and worked with a number of battery manufacturers that utilize or use second life batteries, and we'd like to share, I guess, our observations and insights in terms of the market as it proceeds. So the topic of this session is why battery circularity may stall before it has a chance to start, and this is really a commentary around the market itself. So next slide, please. So just very generally, there has been early promise in terms of circularity batteries, specifically that of using EV charging batteries for a second life for energy storage. But this is being somewhat stifled by, I suppose, three key areas. The first being regulatory inconsistencies throughout various markets, diminishing economic incentives, so specifically the gap between new and second life batteries in terms of price. And the third is the tangible differences, I suppose, between quality and safety of second life batteries compared to the newest innovations and products that are available to the market. And the key point, I suppose, is that without addressing these current growth barriers, second life battery applications are likely to remain a niche solution rather than a scalable and sustainable one. Next slide, please. So here I've tried to put a graphic together that sort of shows, I suppose, the life cycle, the typical life cycle of an EV battery cell. And what you can see here essentially is that once the battery is made from new and put into a vehicle, there are three essential pathways that happen on that battery after use. So the use case or typical use case for an EV charging battery is quite harsh. There's a lot of braking, a lot of regeneration. So, you know, in terms of usage, it's probably the harshest usage method for lithium-ion battery packs. And so at the outcome of, or once they've reached their end of life, there are three real options that happen. So typically, I guess the traditional sense is that the batteries could be just simply discarded, or the batteries could be sent back for recycling, which was discussed earlier in terms of extracting those raw materials and giving and reusing that in the next iteration for materials for the next battery series. And then thirdly, and this is, I guess, the point of this whole session, is to discuss what happens when you repack these batteries and try to use them for stationary storage applications, so giving them a second life. So once you understand, I guess, what we're actually trying to achieve here, so the repackaging of EV chargers, let's start looking at, I guess, the advantage of this. Why have battery packages looked into using EV batteries for second life? Well, there are probably three key advantages here. One is obviously the cost. So initially, I suppose the costs have been anywhere between 30 to 70% lower than new batteries. Because the use case of these batteries is a lot less onerous than batteries used in EV, the battery vendors will, or battery OEMs will recertify the battery for an additional 5 to 10 years. Or at least design the DC side so that they can support another 5 to 10 years of typical use case operation. And then the last is that, you know, it's a new market for what would otherwise have been a wasted or recycled product. So there is a tangible sort of use case for them as a stationary battery system. Next slide, please. So here we've got a picture of actually one of our customers that offers second life batteries, but now we'll focus, I suppose, on what the barriers to growth are in this industry. So the first being lack of standardization. So when you get all these used battery cells, there is a lack of standardization in the materials themselves, right? So where it's the age of the battery cell, the various different chemistries that could be deployed depending on, how old that battery cell is, the voltages that are being packed, as well as the cycles that have gone through the battery. This makes it very difficult to get a standardized product when you're repackaging the battery cells. Next is that there is a continued fall in manufacturing costs for new batteries. So whilst initially there was a sizable gap, as I mentioned before, 30 to 70%, there is continued downward pressure applied from innovation in battery cell manufacturing that basically means that new battery cells or new battery technologies are putting downward pressure and reducing this gap. Next is the safety testing and certification gaps. So there's no universal standards for state of health, safety protocols or performance guarantees. From a regulatory perspective, there's a whole lot of middle ground or no man's land when it comes to standards and adoption. So there is UL 1974, but still a very low uptake on this. Liability is unclear, as is end-of-life responsibilities for these second life batteries. Maybe one of the most important things, especially coming back to cost, is the high labour intensity. So basically what happens is when you have these batteries, you have to strip them out of their existing frame. EV chargers are usually flat and thin sort of profile. You're repackaging these battery cells into stationary storage cells with different voltages and balancing accordingly. It's a very hands-on task. And last is buyer perception. So just imagine, I suppose, the case where you have the choice of going into a car yard, you have a brand new car versus a second-hand car. There is certainly going to be vendors in the market or customers in the market who prefer to buy new as opposed to second-hand. Next slide, please. So, final observations. Second life batteries are a novel concept. It's great to be able to reuse battery storage, especially when sustainability is key for the environment. To progress though from this concept of being from concept to legitimate product, there are three probably key issues that need to be solved. The pricing differential, as I mentioned before, safety and quality levels can't be compromised. And then there's the piece around perception on second life products that needs to be challenged from a marketing or branding exercise. And next steps. So firmer guidelines on second life batteries, standards to ensure that both quality and safety levels are maintained, assured, and you're getting a commensurate product between new and second life. Innovation in the disassembly, repacking and manufacturing processes to reduce the cost of reutilizing batteries for second life applications. And lastly, there is, I think, a significant onus on government and financiers to provide better financial or tax incentives for investment in second life batteries. And these, I suppose, are the next steps which would be necessary to change this from concept or niche sort of market to sustainable market vertical. And that is my time, I believe. So I hope that you've all been able to learn something from this information session, and more than happy to answer any further questions you might have. Thank you.
Thanks a lot, Chris. Very informative and interesting presentation. Thanks for bringing circularity to the table and also for showcasing all these challenges that they are facing for the circularity. ARE is very concerned about many of these topics like safety, certification, standardization, and so on. So yeah, thanks for bringing this topic. Just a reminder, dear audience, please share as many questions as you want. We are collecting them, and we will be happy to answer them during the Q&A. So yeah, thanks a lot, Chris. And now is the turn of the fourth speaker, that is Jess. Mr. Tomas, who is the general manager of Novum Solar Peru, who will give a different angle from the perspective of the sector in Peru and what Novum is doing in the country from many years ago. So it's really a pleasure to have you here today, Tomas. And yeah, the floor is all yours. Thanks.
Thank you very much, Carlos. And thank you also for welcoming us in I4E. We are recently new members to I4E, and very happy to meet other companies that are doing a lot of things for rural electrification. Novum Solar is a company that I founded with my partner in 2017. We have been working in the sector since that year, and having been doing a lot of projects both in the on-grid and off-grid sectors. Please go to the next slide. We have been accelerating the energy transition through solar energy with more than 50 megawatt in off-grid project development and execution. I don't know why there's a problem with the numbers there, but I will read it out to you. We have more than 20 megawatt in executed solar capacity and more than 25 megawatt hour in projects in storage projects in operation. Next slide, please. Here is a brief summary of our timeline as a company. I will not get into detail, but what I wanted to mention here is that we've been doing from really small projects, both in the on-grid and off-grid sectors, back in 2017. In 2020, we did our first 2 microgrids, and we have been growing in size of projects and complexity until 2024, that we commissioned our biggest project yet. I will probably go into more detail afterwards. Some challenges in, next slide, please. Some challenges in the Peruvian energy sector, both in the on-grid and the off-grid, focused in energy storage solutions. We have in the on-grid high demand charges for peak consumptions. We have a lot of instability, specifically in the end of the distribution networks, and also a high operational cost due to usage of diesel in certain areas. And in the off-grid sector, I think it's very similar to the challenges that maybe other LATAM countries face, that transmission lines are not always reaching small towns, especially in the Amazon, and there is a high usage of diesel in these towns, which means there is a very high cost of electricity in these areas. Next slide, please. What we see for the energy storage as opportunities in the on-grid, there's a very good opportunity for peak shaving. I think this is also very popular in other parts of the world. In the right, you can see a picture of a system that we installed in a mine around 3,000 meters above sea level, and 8 megawatt hour storage that's doing peak shaving and also optimizing the cost of electricity for this operation. And also in the off-grid, we see that this energy storage can have a very big relevance as a grid forming solution to ensure that remote operations and communities can enjoy stable and also cost-effective energy solutions. Next slide, please. And this is, I think this is the most important slide that I wanted to mention. We have been powering the Amazon with solar energy and storage through an affiliated company of Novum Solar called Amazonas Energía Solar, which is a joint venture between Novum Solar and EDF. here we have a portfolio of 10 projects that it will benefit more than 100,000 people and will avoid 500,000 tons of CO2. These projects are renewable power plants mixing solar PV and energy storage with a total capacity of 33 megawatt and 46 megawatt hour in storage during the first stage of these projects. In the map on the left, you can see 5 projects in green, which are the projects that are already commissioned and working. You can see Requena, for example, is the largest plant with a 7.5 megawatt peak of solar capacity and 9 megawatt hour of storage installed. The picture that you see in the bottom right is the Requena plant, which is a very nice picture of how the project today looks and how it's solving the energy access problem in this community. The other 5 projects that are in blue on the map are projects that are currently under development and starting construction in this year and the next year. Please go to the next slide. So the isolated electrical systems, as the ones that I mentioned before, are small cities in the Amazon that are completely disconnected from the main grid and don't have access to stable electricity due to the typical issues of operating diesel generators in these kind of areas. They lack of maintenance, they have high operating costs, and this altogether creates a very insecure and unstable energy supply for the people that lives in these places. Next slide, please. So our solution are smart microgrids. What we've been doing in the Amazonas project is to install a solar and storage capacity at the medium voltage level in these communities, AC coupling with the existing diesel generators, improving the diesel generators system to be more efficient and create a microgrid to be able to supply 24/7 energy access to the end users. So in these projects, what we've been doing is installing in the end energy management software that can automatize the current solution and provide electricity to all these users. And please go to the next slide. So about the BSS lifespan, we've been using top of the line technology with reliable suppliers to be able to ensure more than 20 years of state of health performance with contracts and warranties that can ensure that these batteries are done correctly and manufactured correctly. We believe that the circular approach for this type of storage solutions can be in a way having a second usage of this type of batteries for other type of projects. And at the end of life, certainly we believe that it's critical to be able to recycle most of the materials that are being used to manufacture these battery cells. So next slide, please. I think this is all. I wanted to end this with a picture of our projects and be able to just share with you these pictures that for us is a team effort from all our company to be able to do these projects and benefit many Peruvians. So thank you very much for your time and happy to answer any questions.
Thank you, Tomas. Great presentation. Thanks for guiding us through the work of Novum, all these beautiful pictures, all your efforts and all the particularities of Peru and also South America. Especially interesting, the electrification of the Amazon. So I hope we'll get some questions about that. Now moving to the next slide, I have the real pleasure to invite the next speaker of the day. That is Jan Bortel Trenck. under Trenck, and he will be showcasing the work of Free Europe in multiple sectors, such as mini-grids, CNI, productive use. So it's going to be a very complete presentation. And yeah, over to you, Jen. Thanks a lot.
Thank you very much. I hope everyone can hear me.
Yes, we can.
I have the pleasure of introducing Off-Grid Europe today, and to showcase how Off-Grid Europe offers energy independence worldwide, mostly and exclusively in Africa. Now, on the next slide, please. I would like to introduce the company a little bit. Off-Grid Europe was founded in 2009, once being the largest solar cell retailer in Europe, moved on to battery storage solutions, and is now today a battery storage provider in installer EPC plus F in Western and Southern Africa. The two people you see in front of you now are our founders, Christiane Krag and Mark Krag, that are the brain and masterminds behind the organization and the products that I have the honor and pleasure to introduce to you today. Now, on the next slide, I want to introduce you to our solutions that we have. You can move on 2 slides, actually. One is just stating our solutions. The last slide after that. It all started with mini grids. Now, there are a couple of mini grids and battery storage solutions. You can move back one, please. That have been shown throughout the world, but the largest, or one of the largest that we've had so far, is in Senegal, where over 200 villages were electrified with our mini grids. You can see them here on the top right. It's a battery storage solution, containerized battery storage solution with a sun hat mount on top of it, which provides shades through the solar modules that are put on top, ensuring that the container can be cooled as well as use as little space as possible to electrify the villages that you can see there in the background. Through this experience and many other experiences that were held throughout the project, a couple of other products have come onto the field, and a couple of products were also improved. The smallest battery that we have basically is the solar home system with its 640 watt hours that is installed by putting a module on the roof and then feeding that down into the house, where you have this solar home system that can be attached to different applications, lamps, tablets for charging your phone or tablets. You can put cooking ware, TV, and due to the battery, it can also be used at night. So for instance, kids can keep on studying, even though the lights outside, it's dark, they can use lights. And it is also, we call it hackable, meaning these white knobs that you see there allow you to attach cabling to it, which is oftentimes done by breaking the USB ports, and here you don't have to break the products for it. It has an enabled language module through you can speak with it, and it speaks back to you, meaning that it can also be used in regions where literacy could be an issue, for instance. And it has a pay-go system, meaning that while we do not manage that ourselves, it is there and usable for any government or organization or company that would like to. However, if we move to the next slide, I'd like to introduce you to the main bread and butter of the company, the largest battery storage solution that we have, which is the OMS box. The OMS box is our best battery storage solution, but it's a little bit more than just that. It's a true all-in-one system, as it integrates many products or many features that usually require third-party services. For instance, it has an integrated ATS system, meaning that you can hook it up to the grid as well as diesel generators, and it switches between which is best for the client or whichever building it's attached. In less than 10 milliseconds, it switches, which is not even a flicker in the light, which is especially important if you, for instance, production halls or hospitals or hotels where the smallest outages can be life-threatening even, or cost a lot of money in case of production. It has an overload capacity of over 300%, meaning that it's perfect for black starts. It uses lithium-ion phosphate batteries for a very long life cycle. It can be scaled down to 135 kilowatt hours and up to 265 kilowatt hours per unit, that is. So if you put multiple OMS boxes next to each other, you can scale it up to megawatt systems, which I have an example of in a second. And it has an integrated battery management system, the off-grid controller, that is also an in-house creation. It is a true turnkey solution, meaning that we install the OMS box, or it can be installed for you. You can hook it up to a PV solution or the grid or a diesel generator, which in case of the PV solutions we are also installing, and it can be used almost immediately. So it has everything integrated into it, including fire suppression systems. It has HVAC system in the back, so air cooling. It has fast installation, as it has a forklift and crane ready base. It has a very compact footprint with a 2.3 to 4.5 meter frame, and the enclosure has an IP55 rating, meaning that it can take basically anything that comes towards it. And that's really what makes the OMS box sets it apart, is it's really created for the African market, as it can take anything that the African continent throws at it, but it also provides anything that would like from it. In the next slide, you can see what the markets are in which the OMS box is applicable. The OMS box can be used, for instance, in the public services, where it can enhance sustainability, reduce carbon footprints, ensure reliable power for critical infrastructure. An example here, for instance, are ATMs, which can run 24/7 without you. And on the bottom right, you see a setup of OMS boxes set next to each other. This is a hotel in Cabo Verde, where we installed 1.6 megawatts of battery storage together with 1.2 megawatt peak of solar modules, and leads to the hotel now being able to save up to 450,000 euros a year on electricity costs, ensure that they have a stable electricity supply for their guests, so that they are ensured the best holiday that they can have. It can be used for industrial manufacturing. I mentioned earlier, for instance, for production. It's very, very costly if a production comes to a standstill, and it's a very bad situation if it's just because you can't get electricity. Grid services, in terms of infrastructure, you can either create a sustainable grid, or you can make sure that, for instance, telecommunication towers are 24/7 electrified, which are often set in far off places where the grid isn't applicable, so they're running on diesel generators. And with the help of a small mini grid and with the OMS box, you can then ensure that they're running 24/7 and everyone has connection. Rural communities, like I stated earlier, the electrification of over 200 villages in Senegal can be achieved through the OMS box and the SunHat solution and PV modules. And agricultural processing. Now, agriculture, farming costs a lot of electricity, costs a lot of energy. Oftentimes, it's nowhere near the bigger cities, so very far away from grids in some cases. And the OMS box can then there be used to, first of all, bring electricity to these farmers, but second of all, also be used for post-harvest applications. On the next slide, please. You can see one of the applications of what we believe, or what we know the OMS box can be used for. At least in Senegal, we've made the experience being in the region for lots of time, that 37% of all agricultural production is actually spoiled due to the fact that the storage products cannot be stored properly and cannot be cooled. So they spoil in the markets, they spoil on the fields, and one farmer stated he's really feeding away his money to his goats because he can't sell the products anymore. This is where the much cooler comes in. The much cooler is an on and off grid solution that cools the products from a temperature of 1 to 35 degrees allowing the production, the foods to not spoil and be used for as long as they can. So this is one of the applications where we see the OMS box can really thrive and where it can help. On the last slide, you can now see a QR code. And the QR code would bring us to the download center, where you can download any more information that you might be interested in the products, as well as the company. And on the left, if there are any questions or you're interested in talking to us about your own needs, please feel free to contact me anytime. And that is my time. Thank you very much for listening. And I hope I was able to bring some information across.
Yeah, thank you very much, Jan. Sorry to cut you. I was enjoying so much the presentation. Congratulations, the Off-Grid Europe, for developing all your different technologies, especially the OMS box. Really interesting, and I guess we'll have many questions about that. So yeah, thanks, Jan. And now for the last presentation of the day, I have the pleasure of inviting Mr. Drew Lebowitz to speak. He's the managing director of PowerSwitch. He's a battery storage expert, and yeah, he will be doing a very interesting presentation about what can the rural electrification learn from the utility scale batteries. So very interesting. Thanks, Drew, and the floor is all yours. Thanks.
Great. Thank you so much, Carlos. It's a pleasure to be here today. As you mentioned, my name is Drew Lebowitz. I'm the managing director of PowerSwitch. PowerSwitch is a US-based energy storage advisory firm. So we're a consulting shop that works on really big energy storage systems. Kind of at the small end of what we work on would be about a 10 megawatt system, up to the big ones are now exceeding 500 megawatts. So very big scale, but today's presentation is going to talk a little bit about what we've learned in that sector and how that has informed rural electrification. Next slide, please. A quick bit about PowerSwitch. As I mentioned, we work on some really big energy storage projects. Most of what we do is owner's engineering. So we work with developers of those projects to do procurement, selecting the ideal battery for the application. We do independent engineering, mostly around the financing of energy storage projects. And we also do trainings and expert witness work in the field. I got my start in my career in energy access. I worked in Haiti running a mini grid developer there called CEGASA. And because of that, I sort of still have a place near and dear in my heart for energy access and everything that's going on in Africa and across the world. I still am involved in Haiti and renewable energy. So we still do some pro bono and discounted work in energy access in addition to the work that we do in energy storage. I was the author of The Best Book, which is a book all about utility scale energy storage. And that's you can find a link to that on Amazon. Next slide, please. Here's just a couple pictures of the types of projects we work on. As you can see, they're almost all containerized storage solutions. Most of them come with 20-foot shipping containers. Lithium iron phosphate has become by far the leading chemistry. And we've also seen that the inverters also tend to be really big. On that lower right picture, you can see on the left there, that's an inverter that is about a 4 megawatt inverter in that one unit. Next slide, please. Here's a view of what these systems typically look like. You can see that there's the energy storage containers. There are the PCSs or inverters and transformers, and those feed in typically through a substation that is generally located next to a high voltage utility substation. So obviously much bigger than a lot of the rural electrification solutions, but now I'm going to talk a little bit about what we're seeing in that market and how those changes in the large market are affecting products that are used in rural electrification. Next slide, please. So the first insight is costs are falling. So you can see here a chart of, this is the cell on the bottom and the pack on the top. The packs, also referred to as modules, is sort of the building block of energy storage. And you can see in a little over 10 years, those have fallen over 700%. So what used to cost $800, and this is all on a kilowatt hour basis, is now costing about $115 a kilowatt hour. These are prices that are seen for the export of these systems, but within China, where most of these systems come from, we've seen even lower prices. In some cases, this has gotten down to $70 a kilowatt hour, which is really just opened up huge new markets and new products that never used to be applicable when the costs were so high. You can see on the bottom a graph from 2020 to 2024 of how many gigawatt hours of energy storage was deployed around the world. And it makes sense that as the costs have fallen so quickly, the deployments have picked up. I think this year or last year in 2024, we were about 160 gigawatt hours, and we're on track to almost double that up to nearly 300 gigawatt hours this year. The AMDA report that came out recently talks about the cost per kilowatt of hybrid systems of diesel relative to those that use only solar and battery. And as you can see, battery is still more expensive. If you look at the life cycle of those costs, so this is looking just at a CapEx basis. If you look at the life cycle, the hybrid battery and PV are much cheaper, whereas the diesel hybrid, and to be clear, diesel that's still using solar but without batteries, that's cheaper on a CapEx basis, but in the long run ends up being more expensive. But the lesson here is that as costs continue to fall, and they are expected to continue falling, that PV plus BESS number will become much more competitive, if not even cheaper than the diesel hybrid solution, meaning that diesel will still have a role to play, but as batteries get better and cheaper, they'll have a bigger role in the equation. Next slide, please. The next development I want to talk about here is the rise of the AC block product versus a DC block product. When I say AC block, what I'm referring to is that the enclosure, most of which are a 20-foot shipping container, as we saw in some of the other presentations, actually includes the inverter inside of the product. The Tesla Megapack on the top left there was the first one to do that back in 2022, and it was seen as an outlier then, but now a lot of the products have moved in that direction. Not all of them. There's still maybe a 50-50 split. But the benefits to having an AC block product are that they're going to put out three-phase energy right at the terminals, meaning everything inside the enclosure includes the energy management system, and includes the inverter, and includes all the power electronics and cooling system that are necessary. And I think this is a really great solution for a lot of energy access applications because they're being installed in so many remote locations. Some other benefits are if you get a warranty on this product, you're getting a warranty not just on the battery, but also on the inverter. And of course, inverters are one of the things that can fail the most. So I think over time, we're going to see more and more AC block products, meaning products that come with an inverter baked in. And I think it's a really a boost for rural electrification opportunities. On the right here, you can see some of the leading products in this space. Next slide, please. The last innovation that I wanted to talk about was in the thermal management system. So if you look back about 10 years ago, about 90% of all the utility scale energy storage products were air cooled, meaning they had like air conditioners on the outside of the containers. And 10 years later, 90% of them are liquid cooled. So as we saw also in the other presentations, liquid cooled has really become the dominant way to cool batteries. On the face of it, it might look like a bad idea to put liquid so close to the batteries, but it turns out that it's much more efficient at cooling, and especially in the hot and humid environments where a lot of these systems are being installed, liquid cooling really helps to extend the life cycle. We're starting to see 20-year warranties, meaning over 7,000 cycles in a warranty for these systems. And that can only be maintained if the cells are kept really cool, ideally at 25°C. And that is done through this liquid cooling. So I think this innovation really is a great fit also for rural electrification, given the places that these are installed. Next slide, please. So that concludes the presentation. I think these are three innovations that we're seeing on megawatt scale that has a lot of effects on the kilowatt scale as those trickle down. The lower cost, the AC block, and the thermal management really are going to help rural electrification get better on the product side, so the projects can become cheaper and more effective in the long run. Thank you very much.
Thank you, Drew, for sharing your knowledge with us and for utilizing I4E platform to talk about all these ideas that are very insightful. And I think that the audience will really like. So thanks, Drew. And now may I invite all the speakers to turn on your cameras so that we can enter into the Q&A session. We have received many questions from the audience. Thanks, dear audience, for that. So probably we won't have the time for covering them all, but we will try to do our best. So I would kindly ask you to cover the questions in a way that we can answer as many as possible. So following the original order, I will start with Batrica, so with Tomas. Tomas, there's a question from the audience that says, what is the logistics cost of taking batteries to individual customers and bringing them back for charging? Is it a significant cost for the overall model? Thank you.
It's a very good question. Thank you for that. No, the cost is very, very little. And in fact, the cost is within the rental price, meaning that during the presentation, I mentioned that we are, per villages, we are training 4 persons coming from the local community. And those 4 persons, called Batrica agents, their role is to deliver the batteries, and they are paid per battery rented. So the end customer does not have to pay anything to get the battery delivered to them. So no, the costs and the logistic is fairly small, especially because the customers are also very close to the charging station.
Thank you, Thomas, for answering the question. I think it's very clear now. Next question is for CEGASA, so for you, Mikel. The question is that possible to get an overview of the set of electrotechnical experiences or testings that are currently being carried out in your laboratories? So if you cannot disclose that information, maybe I would invite you to talk about a new technology that you are exploring, or to directly answer the question if that's possible.
Yeah, no, right now about the current tests that are being carried out in the laboratories, I cannot talk about that much, but we always say to our customers or clients that whenever they want, if they want to come to our factory to make a visit and see how we work and also show the laboratories, we could do that. But about regarding the type of tests that we do in laboratories and well, the cycling tests and all of the tests, the different tests that we do, not really, no.
All right, thanks, Mikel, and I will share with you the contact of the person in case you want to elaborate on any point. So thanks for that.
Perfect.
Now there's a question for Chris about circularity. The question says, which sector is best suited to solving and addressing the current problems of battery recycling? Probably the automotive industry or waste sector has more funds available than the VRE sector. So what support is needed to turn battery recycling into a proper industry itself? Thank you.
Okay, it's a good question, but I suppose from my side, the recycling piece was not necessarily the focus of the article. What we were specifically talking about was reuse of the battery as opposed to recycling, so using it in a second life context. To be fair, I think I'm probably the wrong person to ask about recycling because, as I mentioned before, ComAp is a technology business, not an energy storage business. But I suppose more than happy to reach out to the individual and provide some context to our industry partners that might be able to answer that better than what I can.
Okay, thanks, Chris. You got more questions. So, for example, there's a person who wants to clarification on what do you exactly mean by lack of standardization? Is that in the battery manufacturing or in the safety?
Yeah, I think I spoke about a few things. So I spoke about standardization, and I spoke about regulations. And the point is that in terms of regulations around repackaging of batteries and what qualifies as fit for use or fit for purpose, the guidelines are inconsistent from territory to territory, region to region. And so I suppose the point is that, and where there are standards that exist, like I mentioned, UL 1747, I believe it was, that even when there are standards in terms of reuse and how battery storage or how second life battery systems should be used, there's an adoption or a lack of, how do you say, enforcement on the adoption of these standards. So I guess the key point that I'm trying to mention is that with such loose sort of constraints or barriers or quality requirements in terms of this process of moving from suitable use for EV to second life for energy storage purposes, the challenge is that it sets, I guess, conditions for poor performance, poor outcomes, and more or less, chops the opportunity off at the knees before it gets a chance to start. Because the point is that once you undermine consumer confidence in terms of outcomes, then it basically destroys the market for all those good actors in the market. So this is kind of the key point.
Thanks, Chris, for the response. Well noted. Novum Solar, question for you, Tomas. There's a person asking if Novum Solar is manufacturing their own equipment, and if you consider that manufacturing equipment is going to be the future or the best solution for rural electrification. Sorry, we cannot hear you, Tomas. I don't know if you're muted. If you can kindly.
Yes,
unmute.
I think the question was about the equipment, but I missed the last part of your question. Yes.
The question says if you consider that manufacturing equipment is going to be the future or the best solution for rural electrification. Also connected with the first question, if you are or not manufacturing equipment.
Okay. No, we do not manufacture equipment. We actually we procure the equipment globally from big manufacturers that develop technology and have a scale to offer the most competitive prices and also the quality that the projects that we do require. I think manufacturing for a company like us that we're more dedicated to the technology, to integrating the technology and to designing the projects, financing and building is not something that we aim to do. We leave that to the big manufacturers that have been mentioned. I think in the webinar. Yes.
There's another short question that says, can Novum Solar Storage store all energy through its BESS, or can excess energy sometimes not be stored for the long term?
I think it's like the question is if all the energy can be stored, and if not, what do we do with that energy?
I think that's the
Okay. Yes, in normal conditions, the design of a microgrid is done considering average days of sunlight. So in this type of conditions, we have to consider a higher capacity of PV installed in order to always ensure that the batteries are fully charged. So in normal conditions, the batteries will always be fully charged, but that means that in very high high radiation days, I could say that, the batteries will be charged very early, and then you will have excess solar that will have to be curtailed in these type of situations.
Thanks, Thomas, for answering the question. Now moving to off-grid Europe presentation. Question for you, Jan. There are a few questions about the electrification in Senegal. In particular,
yes.
What is the name of your project or program in Senegal? In which area are located the 200 villages? And yeah, what's the status with that villages?
So the project was called the Acer 300 project, where together with the Senegalese government, the 200 villages or over 200 villages were identified, and they aren't really in any specific regions. They're all over Senegal, so they're really distributed everywhere. And then together with other companies, we identified and then went there and then electrified these villages using the solutions that were seen earlier in the presentation. And then during these electrifications, it was kind of the process of finding out that these containerized solutions can be made smaller as well. So from that, moving onward, the process started of creating the OMS box, and that's how that product was created. It was optimizing throughout this whole process.
Thank you very much, Jan, for the clarification.
Thank you.
Yeah, we've got more questions that I will share with you after the webinar. Now, the last question of the day will be for Drew. There's a person asking, how do you want to make sure, or I guess, how can you make sure that the liquid for cooling is available in remote places? Because the main risk is availability at all times.
Sure, yeah. So these products that I'm talking about, but you could say the same about smaller scale products. If they come with liquid cooling, all that is integral to the system. And so usually there's a product warranty, a performance warranty, which will guarantee a certain level of uptime. You know, now we're seeing warranties of up to 98% uptime. And so you have to respect the operating parameters, so you can't, you know, pull too much amperage or do other things. And then it would say an ambient temperature. So as long as you're operating within the ambient temperature range, which is quite large, it goes up now sometimes to 45 degrees C. So covering almost all temperatures, then the liquid cooling system does its own thing, and that is responsible for doing all the liquid cooling, and it sort of just runs itself, which is nice. If it does have an issue, you would see that and you would have to have a technician come, but the availability is part of the performance guarantee that you pay for as part of the warranty. Usually it's called the long-term service agreement, or LTSA. You pay that every year in exchange for that uptime.
Fantastic. Thanks, Drew, for the answer. Ladies and gentlemen, we have come to the end of today's webinar. First of all, I would like to extend our thanks to this wonderful panel that I have with me, to all the speakers representing ARE members. Thanks for your efforts and for your presentations. I think it's been a really insightful webinar. Also, I would like to extend our thanks to the audience. Thanks, dear audience, for your patient hearing and for all these many questions that I will have to send to the speakers so that they can answer to some of your doubts. So yeah, thanks also for being here today with us. And finally, thanks to my organizing team, to Julia, Okan, and the rest of the colleagues for the support of today, and Francesco also for taking care of the presentation. If we can go to the next slide, I can also talk about our flagship event, the Energy Access Investment Forum. If you want to meet us in person, and probably some of the speakers of today, I would say, you can join us next year in Kenya. We'll be doing our EIF from 21 to 24 of April 2026 in Kenya, where all our community will be there, and you will have the chance of meeting like-minded companies and speakers. So thanks for your attention, and looking forward to meeting you in the next edition of I4E on 30th October. The topic will be digitalization and optimization. So looking forward for it, and have a good rest of the day. Thank you all.
For having us.
Yeah, bye.
Thank you very much.
Thank you. Bye.